Here is one of the hardest Edexcel vectors questions. Do you know how to tackle it? Part A is fairly straightforward. We've just been asked to express FE, which would be A minus B plus A plus B, and simplifies to 2A. The second bit is where it gets trickier. M is the midpoint of DE. X is the point on FM, such that fx to xm is in the ratio n to 1. CXE is a straight line, work out the value of n. So first draw the line CXE that they've referenced. As you can see, this crosses through the line where we have our ratio fxm. So we need to find two vectors from this line CXE. The first one, which I think is easiest, is CE. Then I'm going to work out CX. I'm going to go from f to x, so I need to know the vector of f to m first. And then, because f to x is a scale that we don't technically know, I'm going to convert the ratio n to 1 into a fraction for this side. So for the f to x side, we should get n over n plus 1 as our fraction. Once you have your two vectors from that line, you need to expand and simplify to make sure you get all of the a's together and all the b's together. When you've done that, we can now create two equations for the coefficients of a and the coefficients of b. The coefficient of a in the first vector is obviously 1, but we can't say that that is exactly equal to the coefficient of the second vector, because if you look back to the line, they're not the same length, so therefore not the same size. So I need to bring in another scale to represent this line here, CXE. I'm going to use x. I'm going to multiply it by the side that looks easier, which is obviously the side where the coefficient is just 1. So 1 times x is x, and that would equal to the coefficient of the smaller side. Now we need to do the same for the coefficients of b, using the same scale x, because we're still talking about the same line, and put the x on the same side. So where the coefficient of b is 1, 1 times x is obviously just x, and that equals to the smaller side. Now that I've got two effectively simultaneous equations, I can solve them to find n. Because they both equal x, I can just make the right-hand sides of the equations equal to each other. Now I've got an equation with just n in it, so I can solve it. Now that I've got rid of the fractions, I can expand and simplify everything, and now collect the like terms. Move everything to the left to have a quadratic equal 0, and factorize, and finally solve. We obviously have to use the context to choose if n is 4 or 1. As you can see by the ratio, it's more likely to be 4, and also you can see it's clearly bigger in the diagram, so n is 4.